Hello, I'm recording the second video as part of my AWS Machine Learning Specialty Exam Prep course to help potential candidates who want to sit for the examination. And today we're going to cover the second part of the course, which tackles of exploratory data analysis of the exam. And as we know, as data scientists, exploratory data analysis is like a primary step while developing end-to-end ML project. And it simply allows data scientists to drive insights and observations on the data and what kind of transformation they should apply before giving the data for ML training. So what we're gonna do on this section, what are we gonna cover? We're gonna cover the tools and techniques that allow to understand, analyze, and prepare data for ML modeling. We're gonna follow the same strategy as the previous video, where we're gonna cover the content of the main topics. And then we're going to end up with sample questions, which help us test what we covered and give us also a taste of real exam questions. The main topics that we're going to talk about in this section can be summarized in the slide, where we're going to talk about data distributions, feature engineering techniques, such as to handle missing values, outliers, class imbalance. Then we're going to talk about data transformation and encoding. We're going to touch on data shuffling, AWS QuickSight, AWS Athena, and AWS Ground Truth. If we start to talk about data distributions, so we mainly have different types of data distributions, but they can like fall under these three sections. The first one, it could be probability density function, which it's a probability distribution of a continuous random variable, such as the probability of observing different heights within the population. So when the variable that we are testing is considered to be continuous, then we should expect to have probability density function, and it gives us distribution of this continuous random variable. The second type is probability mass function, which describes the probability of discrete data, such as the number of questions answered correctly in a test, which could be like out of, like if the test has like 10 questions, what's the probability that the student did answer like 4 out of 10 questions correct or 8 out of 10 correct. The third probability distribution is Poisson distribution. And Poisson distribution is a specific type of discrete distribution. So its Poisson distribution is discrete distribution, where it helps us observe the distribution of a discrete variable. That it represents the probability of a certain number of events occurring within a fixed interval of time or space. So if we think of a practical example of Poisson distribution, we can think of call centers, where call centers use the Poisson distribution to model or to determine the number of expected calls that this center will arrive at the specific time interval. So it's the same theme. We are talking about certain number of events. Here we are talking about certain number of expected calls. So calls represent the events which will occur within specific time intervals, such as like within 30 minutes. So this is what Poisson distribution is about. If we dig deeper into more distributions, we can also have Bernoulli distribution and binomial distribution. So Bernoulli distribution is also a discrete probability distribution, which models the single trial with 2 possible outcomes. So whenever we are thinking of a probability distribution which has one single trial with 2 possible outcomes, it could be success represented as 1 or failure represented as 0. Could be Bernoulli distribution. And one popular example is like flipping a coin, which gives us head or tail. So because when you flip the coin, there are only two possible outcomes, and within a single trial, this is called Bernoulli distribution. Uh, Whereas binomial distribution, it represents the sum of Bernoulli distributions. So it's the same idea of Bernoulli distribution, where it's discrete. It models two possible outcomes, success or failure, 1 or 0. But within binomial distribution, we can have different trials. So it's the sum of Bernoulli distributions, and it describes multiple events that exactly having two possible outcomes with the same probability of success or failure, such as probability of a student passing or failing an exam, or probability like of a team winning a championship. So here you have like different trials, but there is two possible outcomes, either success or failure, and it's like multiple events or multiple trials. So Bernoulli distribution is like discrete probability distribution with a single trial and two possible outcomes, whereas binomial is the sum of those Bernoulli, where we have multiple trials with only two possible outcomes, either success or failure. The next topic that we're going to talk about is feature engineering. And I think it's one of the most important topics in data science, where if we are developing an end-to-end ML project, and before getting ready in a stage where we're able to test different fancy ML or deep learning algorithms, we should prepare the data and make it appropriate and properly presented for the model to handle it. Otherwise, we're going to have different errors. So the first the feature engineering technique that we're going to cover is how to treat missing values. So one of the most challenging parts that we could receive a data set from our stakeholders, but this data set might have a lot of missing values, whether in numeric or categorical variables. So what are the kind of strategies that we can think of? The first one is we can think of dropping attributes or dropping rows, in other words, that has too many values, which is like less favorable, because this might end up us losing some potential good data. The second strategy could be to fill in or like replace this missing value with a median or a mean. And it's worth noting that median is better in case of outliers. So if we have a lot of outliers in the data, like we have skewed unnormal distribution, then we can think of the median to be used, which is better in this case. The third strategy that we can think of when treating missing values, we can think of KNN, or K nearest neighbors, where we can find K nearest most similar rows and average their values for numeric data. And the fourth strategy that we can use is to build a machine learning model in the feature engineering stage to impute this missing data. And we can either do deep learning model or simple regression model, but it's worth noting that deep learning works well for missing categorical data, and regression, it works well for numeric data, which helps us to find relationship between the missing feature and other features. So to sum it up, it's very important to know these are the four most prominent techniques to treat missing values. We can either drop these missing values or these rows, which is the least favorable technique. We can use median or mean, or we can apply KNN, or we can build a machine learning model which can impute this data. Deep learning works well for categorical data, whereas regression works well for numeric data. Then we're going to talk about how to treat imbalanced data. So if we are doing logistic regression and we are having two classes, binary classes, true and false, true would be, for example, less represented in the data, or the data distribution would be like 95% for false values and 5% for false values. So we should think of techniques in order to treat this imbalanced data before training ML model. And the four prominent feature engineering techniques to treat imbalanced data, it could be to oversample the minority class. So for example, to oversample the true class if it's underrepresented, or we can think of undersampling the majority class. The third one we can think, which is very well known in the field of data science, is to use something what we call SMOT, or synthetic minority oversampling technique, where it helps us to generate new samples or to augment the new samples to either undersample majority class or oversample minority class. And good techniques in the field, as I said earlier, it's SMOT. And the fourth feature engineering technique that we can use to treat imbalanced data is to adjust thresholds between classes. So if we're talking about logistic regression, we can adjust the thresholds or the probability for the model in which it predicts if the class is positive or a negative. So if we put this in practical example, let's say we're having data set and want to predict a fraudulent outcome. So we need to predict if an event is fraudulent or no. So it's like true or false. And the fraudulent class is highly like underrepresented. So we have like a high imbalanced data. So we can think of oversampling the fraudulent class or undersampling the non-fraudulent class in order to make the data set more balanced. We can also use SMOT to generate more samples or more synthetic samples of the minority class, which is the fraudulent class in this example, or we can simply adjust thresholds between fraudulent and non-fraudulent classes. Also to continue on how to handle outliers. So if we have outliers in the data, or like we have data skewness, in other words, we can think of variance and standard deviation in order to detect these outliers. So variance, it helps us measure how, it's like statistical measure, which helps us measure how the data is spread around the mean. So if the variance is high, this indicates the data points are widely scattered and far from the mean. Whereas standard deviation is also a statistical measure, and it's simply the square root of the variance. And it also indicates the extent of variability or dispersion within the data set. So if we do like a test for data set and we determine the variance and standard deviation, and we find out that there is like high variability or like data points are widely scattered from the mean, then we need to think how to remove these outliers and treat data skewness. And to do that, there are various feature engineering techniques such as standardization and log transformation to standardize the data or to apply log transformation for the data. Good techniques from scikit-learn, it includes, for example, standard scaler, power transformer, or robust scaler. Next, in the feature engineering topic, we're going to talk about how to treat categories and text data. So the ML algorithms expect the data in proper format, and this format, it entails having the data in a numeric representation or create like numeric embeddings or numeric format for the data. So if we have like a data and one of the columns would be, for example, people relates to different classes, and these classes could be high, medium, low. So I need to think of a strategy to convert this category, which is high, medium, low, into numeric. And for this, we use categorical encoding, and which entails like transforming categorical data into some new representation, which is numeric, required by the model. And there are various approaches which we can use in this context, such as one-hot encoding, label encoding, or ordinal encoding in case we have ordinal data or data with specific order. Also, if we are dealing with text data, so we also need to think of a strategy to convert, to transform the text data into numeric embeddings or representation. And there are different techniques also that could be used in this context, such as TF-IDF, which stands for term frequency inverse document frequency, or count vectorizer, or GLOVE, which is like a ML algorithm stands for global vectors for word representation. And what does these do, like TF-IDF or count vectorizer or GLOVE? They take the text data and they transform it into numeric representation, which is accepted by the model. The next feature engineering technique that we're gonna cover is called data shuffling. And with data shuffling, it's a highly needed step in data processing and model training, and which simply helps us to randomly reorder or resample the instances or observation in data set, which helps reduce biases and improve model generalization. We're going to talk about AWS QuickSight. We did cover this in our previous video, but here, like, we're going to talk about from EDA perspective. AWS QuickSight is a visualization tool, which is serverless, fast, easy, cloud-powered business analytics service for data visualization. It has an important feature where data sets are imported into SPICE, which stands for super fast, parallel, in-memory calculation engine. It's worth noting that we have some ML capabilities in QuickSight, and these ML capabilities helps us to identify or to detect anomalies or anomaly detection. It helps us to do forecasting, and it helps us to do automatic generation of narratives. These are the ML capabilities in QuickSight: anomaly detection, forecasting, and automatic generation of narratives. AWS Athena simply allows users to use SQL to access data directly on S3 without moving the data out of S3. So if we are saving data like any Parquet format, CSV, or whatever to S3, we can use Athena to query this data and to extract specific relevant rows and columns, or even perform SQL-based transformation and aggregations while the data is sitting on S3 without the need to move it from there. The next topic that we're going to talk about is AWS Ground Truth, and it's a labeling service which helps us create high quality label training data sets for ML models, because one of the biggest challenges of doing ML with unstructured data, for example, or with unstructured data such as text or images, is that we have high quality, but it's unlabeled data, and we need some sort of labeling data in order to do or to solve some ML problems. And AWS Ground Truth helps solve this problem, which creates high quality labeling training data set for us. Labeling can be done by three options. First option is Amazon Mechanical Turk, which is like AWS stuff, or we can use our internal team to label the data within the AWS Ground Truth platform, or we can hire professional labeling companies to do the labeling for us. So one important feature of Ground Truth as well, Ground Truth can create its own model for labeling. So as images, for example, or text are labeled by people, the model would learn how the labeling would work, and only, for example, images or text the model isn't confident about would send to human labelers. So this takes us to the end of the content or the main topics of the exploratory data analysis section. I hope you find it useful, and now we will start tackling some of the questions which help us test the content that we just covered, and also gives us a taste of the real exam questions related to the EDA section. So, as covered in the previous video, the first strategy is for us to read the question look for keywords, and think of potential solutions that would help us like solve the scenario without going to the given choices. And then we look into the given choices and we select the best correct one. So if you look at question number 1, they are telling us you are a data scientist and you are creating a binary classification model to predict whether a customer will leave the company or not. So this is a churn problem. And during the exploratory work, realize that the account tenure with some missing values. So the account tenure is a numeric variable and it has some missing values. This variable is expressed in real numbers. What would be the fastest approach to dealing with missing values, assuming you don't want to lose information? So the key words here, it could be that we have the account tenure, it has missing values, it's expressed in real numbers, which is numeric, and what's the fastest approach. So they are telling us to deal with fastest approach. So if we go back to what we discussed in the previous slides, when we have missing values, we could think of 4 main approaches. We could think of dropping the rows, which is the least favorable approach. We could think of replacing median or mean. Median is better when we have outliers. We can think of use KNN, or we can think of developing a regression model, which help us to study the relationship between account tenure and other features. These are the 4 potential solutions. They're asking us for the fastest approach. So they're telling us option A, to drop the missing values, which is least favorable and not recommended. Option B, create a regression model to predict the account tenure and use it to predict the missing data. It could be, but it's more advanced solution. Create a deep learning model to predict the account tenure and use it to predict the missing data. As we discussed earlier, deep learning model works better for categorical data, and it's more advanced solution. And option D, replacing the missing data with the mean or median value of the variable. So in this scenario, we'll definitely go for option D because it's the fastest approach and it helps us to retain the data that we have and to treat the missing values. So we could either replace with median or mean. If, for example, they did mention that the data has outliers, then we should only choose median. They could like split the options into like D and E. D is for median, E for mean. Then we have to choose the option which expresses median because median is better to be used when we have skewness or outliers in the data. Question number 2, they are telling us you are working on a project to identify solar panels on roofs from footage data. Currently, the business doesn't have much labeled data. What AWS solution would you recommend to generate labeled data? So we did discuss also that. So we could think of AWS Ground Truth, which help us to create high quality labeled training data sets. And if we look into the options here, we have AWS Data Wrangler, AWS Augmented AI, AWS QuickSight, and AWS Ground Truth. And we should choose option D, which is the labeling service available in the AWS. Question number 3. They are telling us you are a data scientist working on a fraud detection problem. You notice that the number of fraudulent examples in your data set is extremely small. What are some techniques you can apply to mitigate this? Choose all that apply. So key problems here, keywords we should look into is number of fraudulent example is extremely low, so we have imbalanced data set. And what are the techniques that you can apply to mitigate this? We did also cover that, so we could think of upsampling the minority class, which is the fraudulent class in this scenario. We could think of undersampling the majority class, which is the non-fraudulent class in this scenario. We could use other techniques such as SMOT to generate more synthetic attributes for the minority class, such as fraudulent class. or we can play with the thresholds in order to help the model to identify fraudulent examples more easily. So if we look on the solutions, so or onto the options that are available, option A, it could be to write a custom loss function that penalizes the model for incorrectly predicting fraudulent examples. It's the same like playing with the thresholds in order to help the model to identify fraudulent examples easily. B, to perform smart upsampling on the fraudulent class, which is the minority class in this example. C, it could be to upsample the fraudulent class. Or D, simply drop the minority class since you have too few examples and the model will not be able to learn from them. So option A is definitely correct. Option B is correct. Option C is correct. Option D is definitely incorrect, because if we drop the minority class, then we will end up with one class only, and this is not a binary classification or fraud detection problem. So we'll not be able to deliver the project. So A, B, and C are the correct answers. Question 4, telling us which of the following is valid data engineering strategy. Option A is to split the data set into train test, standardized training set, use the mean standardization or standard deviation to standardize the data set, then train the model on training and make prediction the test set. So, or option B, it could be to standardize entire data set, split standardized data set into train set, train model on the training data and make prediction the test set. Option C is to split the data into train test, convert categorical values in the training set, and then train the model on the training data and make prediction of the test set. So before training the model, we should think of steps in order to prepare the data. And one of these steps is like to think of splitting the data set into train and test. And when we split the data set into train and test, also we need to, for example, think of standardizing the training data set. But the same standardization process that we apply for training data set, we should consider applying it on the test set in order to help the model to predict on the test set. Otherwise, it will throw an error. And then we should think of training the model on the training data set and make predictions test set. So strategy A is option A is definitely correct, because it's splitting the data into train tests is correct. We standardize the training data set, and then we apply the standardization using the mean or standard deviation to standardize the test set. Then if we ask the model to predict on the test set, it will not throw an error. Whereas if we look at option B, we shouldn't think of standardizing the entire data set, because train set and test set should be treated separately. So option B is wrong. Option C, it's good that we are splitting the data set into train and test, but it's only converting categorical values in the training data set using one hot encoder. And if we do that, and then we ask the model to predict on the test set, this will give us an error, because the model is expecting also the categorical values of test set to be featured engineered to be numeric as well. So we should apply one hot encoder for the train set and the test set separately. And then when we ask the model to predict on the test set, then it will not throw an error. So in this case, option A is the correct answer. Question 5, they are telling us an ML specialist is creating a new NLP application that processes a data set. The aim is to then run Word2Vec to generate embeddings and enable different types of predictions. Here's an example from the data set. The quick brown fox jumps over the lazy dog. So we could see like for example, a mistakes written here as quick should be like with an I. So, and some of them are capitalized, some of them is not capitalized. So they are telling us which of the following are the operation the specialist needs to perform to correctly sanitize and prepare the data in a repeatable manner. Choose 3. Option A, it's to perform part of speech tagging and keep the action and verb and the nouns only. So we can perform part of speech tagging and like determine which of them are verbs, nouns, subjects, but we cannot only like keep the verbs and nouns because this will let us lose another variable data as well. Option B, to normalize all words by making sentence lowercase. Yep, this is very variable approach. We can make it using word.lower. C, to remove stop words using an English stop word dictionary. Also, this is a needed step. We can, for example, use the stop words package from an LTK library in order to perform that. Option D, correct the typography on quick to quick. This is like unreasonable to do it because this is only a sentence, but we could have like 10,000 sentences and it's unreasonable to correct each sentence separately. Option E, to use one hot encoder on words in the sentence. This is like also unuseful because because we have different potential combinations between if we gonna like one hot encode each of these words. And option F, to tokenize the sentences into words, and also this is like very needed processing step in NLP work, and we can use the word tokenize package we can use the word tokenize package also from an LTK library, which helps us to tokenize the data set. So out of these 6 options, we could choose definitely option B, which is to normalize or make words lowercase. Option C, we should definitely remove stop words or like unrepetitive, unneeded, repetitive, common English words. And definitely we should think of option F, which is tokenize the sentence into words. And this brings up like B, C, and F are the correct answers. So this takes us for the end of this video where we did explain the main content of the EDA section of the AWS ML examination. And as I said in the previous video, this only gives you an overview of the main topics, but you should read more and dig deeper into each of the topics we talked about. How to use it, where to use it, and why to use it as well. There are like a bunch of resources available online. And the next video which I'll be releasing will be about the modeling section, which will be the biggest and the most important section of the examination. Until then, happy studying, and thank you for watching.